Our first ray diagram will be for a converging lens with the object farther away from the lens than the focus. We'll draw a ray leaving the tip of the object going parallel to the principal axis. It will emerge from the lens going through the focus on the other side. A second ray we can draw leaves the tip of the object and passes through the focus before it hits the lens. That ray will emerge from the lens parallel to the principal axis. Those two light rays will cross where the tip of the real image is located. So the light rays actually come together on the far side of the lens from the object, and it is a real image that is formed by a converging lens when the object is farther than the focus. A third ray that can be drawn would leave the tip of the object and pass through the center of the lens, just going in a straight line. It will also intersect at the same location as the other two light rays intersected. For this ray diagram, we'll use a converging lens, but now the object will be closer to the lens than the focus. Once again, we'll start with a light ray going parallel to the principal axis before it hits the lens. That light ray will emerge, passing through the focus on the far side of the lens. A second ray we can draw, which will leave the object as if it were coming from the focus, and that ray will exit the lens going parallel to the principal axis. Since those two light rays, after they pass through the lens, are spreading out, we need to draw extensions of those rays backwards to find where the image will be located. Where those extensions meet is where the tip of the virtual image is located. In this case, the virtual image is magnified. It's larger than the object. In fact, this is what a magnifying glass does. The final ray diagram we'll draw consists of a diverging lens. Here, it doesn't matter how far away the object is. We'll draw a light ray leaving the tip of the object that is going parallel to the principal axis. That light ray will leave the diverging lens spreading out as if it were coming from the focus on the original side. The second light ray leaves the tip of the object as if it were headed towards the focus on the far side of the lens. That light ray will emerge from the lens moving parallel to the principal axis. Again, because these two light rays diverge, we'll need to draw the extensions back, and where those extensions meet is where the tip of the virtual image will be. In this case, the virtual image is smaller than the object. That's always the case with a diverging lens.